teach you guys how to use a digital multimeter. First off, has anyone ever used a digital multimeter before?
I might have, but I don't know what that is.
So, here's one for each of you guys.
Oh, I have used one before.
I think Dad has a couple. Yeah. So, does anyone have any maybe any idea how to use it? Or what it's used for based on looking at it? Anyone
You could jump a
recognize?
car. You could jump a car with this.
No.
No.
Can anyone recognize the different symbols?
One of them is ohms. And all the variations of A and V. Alternating current is one of them.
Yeah, so we got 3 different things with this. So voltage is the V. Then there's resistance. And resistance is measured in ohms.
What's the squiggly line versus the dotted line?
Analog versus digital.
Okay.
And then the A is representing amps, and that is current. So I'll give you guys the analogy I gave my little high schoolers. So imagine there's this flowing river, and then there's a dam, okay? And then there's a person on the top that kind of opens this dam gate, and it allows water in, that kind of thing. So think of water as current, the flow. So it's the flow of electrons, okay? Think of the dam as resistance. It kind of allows how much current goes in and out. And then voltage, imagine if you didn't open it and then the water just keeps kind of pushing up and gets higher and higher. So that force is voltage.
Gotcha.
Cool? Cool. Okay, so on here, so these represent, this is power and
Positive, negative.
positive, negative. Negative is black, positive is red. Okay? And this, you can measure how much. What?
Blocking Mom out.
Sorry, Mom. So, if you turn it to ohms, you can measure how much resistance is going through. So,
How resistant is it?
and you can kind of measure how much goes through each different kind of thing. So, to practice this, these are all breadboard proto boards.
Wow.
Yeah. And we have different components. So I'll give you guys some wires. And I'll give you guys an LED.
Oh, we're gonna make it light up.
Yeah. And then we're going to do it based off of laptop. Because this is the only power sources that I have. So this thing is called an Arduino. Jordan, do you know what an Arduino is? Or have you heard of one? Has anyone ever heard of, or like a Raspberry Pi?
Somebody like that works at like Beto's.
It's not Betos. So, what these Arduinos, so I'm going to kind of tell you what goes in each one. So this is the power, this is kind of like your reset, you kind of reset it. How you get power to it, you stick it, you connect it to here. Ooh, power. So, what you can do is, so do you guys know how electricity flows?
Like water.
Yeah, but like, does it flow
Path
from
of least
positive
resistance.
to negative or negative to positive? Do you guys know?
I don't know.
Not
That's
sure,
okay.
but I
That's
would
why
guess it runs from positive to negative.
the opposite.
Opposite?
So it runs from negative to positive. Okay. So on our Arduinos, if you want to look at your Arduino, so can you guys find ground that's equal to negative? Can you find that on the board anywhere?
Ground?
Ground.
Yeah, it's
There's like 3
G&D?
different types.
G&D.
G&D, good. And then can
Wait,
you
I'm not
find
finding it?
so
Top right.
See the little
top right, and
letters?
also find the other places it says ground. Can you find those places?
So it says ground on
G&D,
power
G&D.
twice.
Good. So, and then up here where it says power, so the V, that represents 5 volts, or 3.3 volts, and that's just how much volts we're going to use, 5 volts. And do you guys know the difference between digital data and like analog data?
No.
So digital is like 1 or 0, on or off. Yes, no. Analog is like, it can be a bunch of different ones, like 2.2, 2.3, it can be ranges, things. It's not just one or the other, okay? And then on the right, these are different like inputs. Those are digital inputs kind of things. On the left, it's our analog inputs. So that's just kind of shows us the different things. So to make an LED light up, so this is called our breadboards, and the red is positive and the blue is negative. So for a way to light this up, so you're going to stick your pin. First we need to plug in ground and 5 volts. So find ground on your Arduino and plug it into ground.
Which ground?
Doesn't matter. Do it on the one on the right, just to make it easier.
The ARF one?
Yeah.
Okay.
So plug it in over there. Okay. Then you're going to get another pin.
Fourth one? Did you do the fourth
Yeah.
one?
Then you're going to get another one of these things. And you're going to plug it into 5 volts on the left.
Digital?
Up here. Just up here on the left. 5 volts.
Oh.
These are kind of hard to line up. What?
Sorry.
It's the 5th one down.
Okay. So if we know that, so let's talk about these breadboards now.
Fourth one.
So this is just kind of to make connections. This is what this is for. So to bring power to the whole thing. So the blue, that's all ground, and the red, that's all power. Power, 5 volts, same thing. Ground, negative, same thing. So you're gonna plug the ground into the blue part. Doesn't matter where on the blue. So you're gonna plug that in. Okay.
The blue part?
Sorry. Here you go.
Which blue part?
Huh?
Anything?
Anything. Because now that entire
The
strip.
ground?
Yep, so now that entire strip has power. Or has ground, but it has electricity flowing through it, okay? Then you're going to do the same thing with 5 volts.
Just anywhere on red?
Anywhere.
Oh, I got there. Yeah.
Anywhere on red. No, it's not enough. Okay, so now we are going to make your LEDs light up. So, electricity flows from negative to positive, so get your LEDs.
Here's one right there.
There you go.
My button's placed.
You have one on? Okay, so when you look at these LEDs, they have a negative and a positive side. So look at, one way you can tell is there's a flat side of the LED. Can you guys find the flat side?
The flat side.
So look at the rim of the LED, look.
Yeah.
And then you see how one side is flat.
Yep.
Do you see it, Lindy?
No.
What's the flat side mean?
That's negative.
But
They
it
look,
runs
they
this
look the
way.
same way. Hey, mine
So-
is not flat. Anyway.
Look at
On
here.
on the plastic
On the
rim
plastic
at the
part,
bottom.
see how that is
Yeah.
flat.
Oh.
But the,
Yeah.
It's
Mom,
on
right
the
here.
outside,
Look
not
on
the inside.
the outside of this rim.
It's on the outside, Mom.
So that one's the negative
I'm
one.
trying, but I don't see
You
it.
see how it's flat? Mom, it's the
Yeah.
very outside.
Oh, wait. There it is. I think that's it.
Yeah, the plastic one.
Okay.
Okay, so
So the flat part is the negative side. Usually it's the shorter, but sometimes it's not.
and then
So on our breadboards, because you want to make a complete circuit. If it's so, it has to go from negative to positive for it to have power to light up. So your board has power, so now you're going to start from negative, and you're going to plug in the negative side of your LED into anywhere on the blue.
Where's the other side going?
through the red.
So for now, so just put one side in there, and then have the other side stick it anywhere on.
The left side?
Doesn't matter, either side. Stick it anywhere on there.
Stick it in.
You can do the other side too, Jordan. You can do it on the side Okay, can somebody remind me the purpose of breadboards?
To learn.
So it's kind of to connect things, that kind of thing. So now we're going to add resistors. So back to our analogy. What
It's
was...
a dam.
Yes. So regarding electricity and current, what are resistors used for?
Slowing down electricity.
Good. So if we're using an LED, why would we need to use a resistor, do you think?
Probably because it's too strong, so you have to slow it down.
Yeah, so if we plug this little baby LED into the wall, it's going to blow it because it's too much
Current.
voltage. Yeah. They can't handle that much. So the reason for the resistor is some of it gets blocked by the resistor and it only allows a certain amount of current to flow through. Okay?
Okay.
So you're going to plug in the resistor. So you kind of your negative, so it goes here. So now you're going to stick the resistor on this side.
Like, it has to be
Yep.
on the outside of the.
Where's
Yeah,
the
'cause-
other up half going?
Hmm?
Where's the other one going?
So stick one over there.
It needs to be on the outside of your. Yeah.
And then one over here?
Okay, and then, so it has to connect to this LED. It goes here. So remember,
Maybe I went
they're
too
connecting the
far.
fives. It doesn't go this way. So you want to stick it there,
And then
like
where?
that. Okay, and so then, why won't this work?
Oh, because
We
it's
have
not a
one.
complete circuit.
Yeah, it's an open circuit. So now we got to connect the other side to the positive,
Right here?
anywhere on positive, for it to be completed.
Is that right?
Do you get it, Mom?
So like that?
Yeah. So, Mom, I want you to explain to me how the electricity flows through.
Oh, God. Oh, me?
No, just kind of what, like,
Okay.
review.
Well, it starts from the ground.
Yeah. Good.
It goes through the sky.
Okay, just tell me where it's kind of flowing.
Well, this ground is flowing to the board.
Yeah. Where? Right here?
No. Oh yeah.
Yes.
To the
Good.
to the
Then
negative
where's it going?
side. To the board.
Yeah, where's it going now?
Where's it going?
Yeah. So electricity comes through here, and it comes over here to the LED because it's in that same row.
Oh yeah.
So it goes through the LED. Then now what?
Then it over into the positive.
Just yeah. So it
Does
goes
it
through
come-
here, over here.
Into the
Then it goes
positive.
through the resistor.
Back to the ground. No?
That's right.
Did I do it wrong?
Sorry.
It hits the resistor before the light.
Yeah. So it doesn't really but it doesn't really matter if it hits resistor before or after because it's a continuous thing.
It's like,
You explain it, Jordan. I don't.
no, you did it.
Okay, Lindy, explain to me how the electricity flows. So how does electricity flow? Just give me a quick answer.
From negative to positive.
Good. So based on that knowledge, show me how the electricity is flowing through here.
Starts the ground here, flows up through this thingy.
This isn't ground.
Oh, sorry, this one.
Good.
Flows up here and then hits the LED light.
Good.
Goes to the resistor
Goes through here.
resistance, and then it lights up the light.
Good. Now, let's see if it works.
It's gonna blow up. It's gonna blow up. So I'm a little confused on my resistor.
It worked.
No, it didn't.
The camera can't tell.
Oh,
Wow. Okay, let's see what's wrong.
maybe I had a stupid wire. Maybe the bulb burst. Maybe it's not
I
pushed
did
in all
just
the
teach
way.
high school kids, so there's a possibility they broke them. But let's put in a different.
Maybe I need a different bulb.
Maybe this thing shows.
Boom.
Is your
Oh yeah. Do you have
resistor?
to open that up?
Oh, no, it's on. Let's see.
I feel like it's shiny. No, it's not. I don't think so.
Let's try one of theirs. Whoa.
We have
Lights.
lights.
Nice. Good. Let's try mom's.
Okay.
That there be light.
Oh, man.